Hello there, and welcome back to another C# intermediate tutorial with the Stride game engine. In this tutorial, we'll have a look at navigation meshes. By the end of this tutorial, we've learned how to set up navigation meshes inside the editor, what kind of properties you have, and then we'll make a script that will allow us to click inside the scene, and our character, represented by this yellow cylinder, it will move around the scene using that navigation mesh, and it will plot a path along the path that has been given back by that navigation mesh. So let's first have a look inside the editor how we can set up those navigation meshes and how controllers can make use of these navigation meshes. You can see that I'm here inside the root of our assets folder, and here we have the game settings, which you always have when you create a new project via the Stride launcher. Once you've selected that, go to the navigation tab where the default navigation settings reside. At first, we have a dynamic navigation mesh setting. If we open that, then we can select whether we want to have dynamic navigation meshes. We're not going to do anything in this tutorial because it's slightly outside of the scope of this tutorial, but to give you a quick rundown, if, for instance, you have a real-time strategy game, then you want to update your navigation mesh once you've placed a new building on the map, because you don't want your characters to walk through that new building that you've placed. So you want to enable this, and you also want to select for which collision groups you want to generate that navigation mesh. Then we have groups. And to illustrate what groups are, I have created two types of navigation groups, the elves and the dwarves. Every time we generate a new mesh where navigation is being calculated for, we can apply certain settings. Now our elves, they have a certain height. And they also are allowed to walk onto certain stairs, like these stairs right here, and they also are allowed to walk on slightly steeper slopes. So with navigation mesh group settings, we can define if a character is allowed to walk on the navigation mesh with these kind of settings. And these settings, they sort of represent the same settings that you would have on your character component, if you're using the character component, or the actual physical representation of your character inside the game. This doesn't have to be some sort of humanoid character. It could also just as well be a vehicle that is allowed to move inside your game using that navigation mesh. Now, an important distinction here between the two examples that I've pre-made is that the elves have a height of 1.2 and the dwarves have a height of 0.5. And also the maximum slope is slightly lower for the dwarves. So for our scenario, or at least that's what we're going to make right now, is that the dwarves would be allowed to walk underneath this walkway, and the dwarves would not be allowed on this slope, while the elves are allowed to walk onto this slope, and the elves would not be allowed underneath this walkway. Now, how about we actually start creating that navigation mesh? Because right now, these are just settings. So if we go to our scene folder inside the Solution Explorer, and I go to the navigation scene, and you can see I've already set up two different meshes, which are being used by the completed tutorial, but we are inside the Start Navigation scene, so let's create our own meshes. So we click on Add Asset. If we type in nav or navigate, we find the navigation mesh asset, and let's create that. Let's rename it to elves mesh. And if we save that, then in the top right corner in the property grid, we first have to select the scene where our navigation mesh should be calculated for. And that is, of course, the start navigation scene that we have here. Then we specify for which collision groups this navigation mesh needs to be calculated. And by default, that's going to be all collision groups. So I'm just going to leave it at that. And just to give you an idea for which collisions that currently are, let's go to the grid and gizmos and select the physics option. And now you can see all these red boxes. These are all the physics that we have in our game. In this case, these are all static colliders. Including these stairs and the walkways. these are the static colliders that that navigation mesh needs to include for its calculation. Then we have these build settings, and these are quite advanced. We're not going to touch these just yet. This is more if you want to play around with how detailed the generated navigation mesh needs to be, then you want to start playing around with these. And by default, they might just be the right settings, but for now we're just going to leave them, and we're only going to come back here if our navigation mesh is not being properly generated. Then we have the groups that are allowed on this navigation mesh. So we can click on this plus icon here, and for this mesh, we're going to say that only the elves are allowed on this navigation mesh. If you would have humanoids as a group as well, or humans, I should say, then you would probably want to add that to this navigation mesh as well, because elves and humans, obviously, they have a somewhat similar size. So let's copy this elven mesh, and let's rename this to dwarf mesh. And if we select that, all we have to do is change this group to dwarves, and then we are good to go. So now we've created the navigation meshes or assets, if you will, but we do not have them yet in our scene. So let me disable the physics view for a second so that it looks a little bit clearer. Now let's make sure that we can actually visualize where that navigation mesh is going to be. And for that, we are going to add some entities. So I'm going to add an empty entity called nav mesh A. And to this nav mesh A, I'm going to add a component. If we start typing nav, then we have this navigation bounding box. I'm going to add that. As you can see, our scene immediately is doing something. It has this, I hope you can see that, it has this bluish box, which is the bounding box of our scene, and it has this green outlay around some of the properties of some of the entities in our scene. And why is that? So every collider that is being touched by this box right now is being included inside the navigation box calculation. So if I move this around, our navigation box or navigation mesh will be updated accordingly. And if I select this floor tile here, notice how it's existing out of a grid base, and it's only this particular size, and that's why it's being included inside that navigation mesh. And let's scale this navigation bounding box so that it incorporates a large portion of our scene. And you can imagine that for this bounding box, you only want to use this for the particular, well, level scenery where your characters actually should walk. So if you have this massive terrain that you're using more or less as a background for your scenery, then you do not want to generate a nav mesh for that entire terrain and just for the parts where your characters are actually going to walk. So we can actually scale the navigation bounding box here manually. We could also just scale the entity itself. Let's just for now scale this. We can leave that at 1. Let's make it slightly larger width, and it's also going to be a Z is also going to be larger. I'm going to move it slightly to the left just to demonstrate how this would look for this particular part of the scene. So I want the stairs and a part of the walkway, and I also want to have this this section here. I want my character to be able to walk there. Let's copy this navigation mesh A, and let's call this navigation mesh B, just as a demonstration how those boxes work. Let's move it slightly to the right and scale that down once more. Okay, this might be a little bit too small. And I want to move it so that the walkway is being generated, but I want this tile to be free. Let's say that this would be some sort of water or something, or another building, then our navigation mesh should not be able to generate there. So this is a good representation of those bounding boxes. Now, if you're not seeing those blue bounding boxes, go to Grid and Gizmo options and select Navigation Bounding Box. Okay, So now we can see that every time we move these bounding boxes around, or if we move any static collider objects around, and these bounding boxes update the nav mesh that is being generated. But right now, our character cannot or would not be able to move onto this walkway because there is no mesh generated. So let's go to that Elven mesh and let's go to the advanced build settings here. And let's tweak a couple of values and see if we can get some green nav mesh in our scene. Let's set that cell size to 0.1 and that looks a lot better. We now have this green navigation mesh going up the stairs and also down this slope, and that's exactly what we wanted. Let's change the dwarven mesh now. We can go to the navigation visibility here in case you want to switch between different types of navigation meshes. We could select all, none, or in this case only the dwarven mesh. And as you can see, this looks kind of bad too, so we have to change that cell size to 0.1. And we now have a navigation mesh that allows our character to walk the stairs, but no longer allows our character to go down this slope. Let's also change the height to 0.1. And now you can see that that navigation mesh is also stretching all the way underneath this walkway. And that's exactly what we wanted. We wanted that dwarf to be able to walk underneath this walkway. So basically this covers this part of the tutorial where we generate navigation meshes in our scene and we can play around with those settings and we can assign different kind of groups to walk along those navigation meshes. So let's go over what we want to do with our code. From our camera perspective, we're going to left click and then we're going to send a raycast into our scene. And once we've hit something, we're going to calculate a new path. And our character, which will have a character navigation component, will then try to plot a path on that navigation mesh. We're going to display the waypoints that we have along the path using a little sphere, and then our character will be moving from one waypoint to the next using some custom logic. So let's first add a navigation component to our character. And the navigation component comes with the Stride engine, and it will take care of calculating that path for a navigation mesh. We have to specify that navigation mesh, which we can find in our navigation scene, and then we select the elves mesh. And we also have to specify that our character in this case is an elf and that it's belonging to the elves group. And let's also add another entity, a sphere that we're going to clone every time we have a waypoint. So we're going to go to models and we have this nice yellow orb that I'm going to place in the scene. It's a little bit too big, so I'm just going to scale that one down. That should be enough. And since we don't want to see this actual sphere, let's also place that underneath the surface. So now let's make our script. So we're going to go to our code folder and let's go click add asset. Let's make a new sync script and let's call this navigation demo. And let's start coding. We first want to have a reference to our character entity. So let's make a public variable of type entity and call this character. We also want to have a reference to that sphere that we want to clone. So let's make a variable sphere to clone. Let's also make a reference to that navigation component, which is not included by default. So we have to say stride.navigations namespace. And let's store that in a navigation variable. And let's initialize that or retrieve that navigation component here. Navigation is character entity dot get and then navigation component. And those spheres, the sphere that we're going to clone, we're going to do that for every waypoint that we have along the path. So we need to store that inside a, let's store those cloned spheres into a list of entities, and let's call these waypoint spheres. Okay. Now inside our update method, what we are going to do there, we're going to say if input is mouse button pressed, and if that is mouse button left, if that's the case, then we're going to do something. Let's first make sure that we are going to set a new target. So we're going to say set new target. That's a new method that we have to create. So let's generate that. And then we need to send out a raycast from our camera perspective into the world. And then if we hit something, then we have our hit result. And this is something that we've done before in a previous tutorial of the projecting and unprojecting tutorial. So I'm just going to copy some code from there. Let's paste that in here. So what we're going to do is we have a near position, which is very close to our camera using our mouse input. And then we're sending out a, direction into our local Z axis, and that will be the far position. So in the far distance. We have to include the stride.graphics for this. You can find this code in the project and unprojecting tutorial if you don't know what this does. Now we're going to make the actual raycast. So we're going to say hit result is this dot get simulation, which we have to include namespace stride.physics for. And then we're going to send out that raycast from our near position to that far position. And our result will be stored in the hit result variable. Now we can say if hit result, if that has succeeded, now that means we're going to calculate a new path. And for this, we do another if statement. And this time we use that navigation component that we've added to our character. And we can use the method try find a path. And our character already starts, at the position that it's already at. And we have to give it the position that we need to want to find a path towards to. So we can say hit result dot point, and this is a world position. And then our end result, our actual path, is being given back or is being stored into a vector3 list called path. And we have to provide this variable ourselves. Let's call this waypoints, and we have to make that list up here. So let's make a vector3 list called waypoints. That's where all that path information is being stored in. These are all separate vector3 positions. Now, for each waypoint vector3 that we have, let's create a new sphere at that position. So we say for each waypoint, for each waypoint in the waypoints that we found, let's sphere to clone. Let's clone this sphere, and we have to add that to our scene, and we also add that to our list of sphere clones. So we say waypoint spheres dot add, and then sphere clone. There we go. And let's also add it to our scene. So we can say entity dot scene dot entities add, and then our sphere clone. We also mustn't forget to, let's also not forget to actually update the position of the cloned sphere. So let's say sphere clone dot transform dot position is the current waypoint in the current for each iteration. And although this will display a new path for us, it will also not remove the previous sphere. So let's do that now first. So let's make a method that says clean up existing path. Let's generate this method, and then we'll have to loop over the existing spheres. So we're going to say another for each here. Let's call this sphere, and we're looping over those waypoint spheres, which is going to be null in the beginning. which is null in the first time we run this because we have not initialized this. So let's say is new list of entities, and let's do the same thing for the list of waypoints. And now we can safely remove these from our scene. Scene.entities.remove, and we remove that sphere iteration. And we can say waypoint spheres, clear this up for us. This is just a lot better. And we do the exact same thing for the waypoints vector3 list as well. Oh, I forgot a parentheses here. So now we can go back to the editor. So we have our character with our navigation component. And if we click on camera, we can add our script there, navigation demo. And all we need to do now is reference in that character. We reference in the sphere that we want to clone. Again, that sphere is currently positioned underneath the surface so that we don't see it. And let's give this a spin. So we click navigation. And every time we click in our scene, a new path is being plotted, and each waypoint will be represented by this yellow sphere. Okay, this is looking good. Now let's calculate the actual movement. So in our update method, we're going to add a new method here called update movement. And this will be called every single frame. However, you can imagine we don't have to do any movement calculations if there are no waypoints. So we say if waypoints.count, if that is 0, then don't bother doing any calculation and simply do a return. And now we have to calculate what our next waypoint is going to be. And for that, we need to keep track of where we are currently at. So let's make a new private variable of integer, and let's call this the waypoint index, which by default is 0, which we also have to set to 0 every time we click on our map. So we go to our raycast, and if we found a new path, we have to set the waypoint index to 0. And our first waypoint at index 0 is our first target. So inside our update movement script, we can retrieve that new target. So we can say next target or next waypoint position, next waypoint is waypoints with the waypoints index. Visual Studio already suggested it for us. Then we also need to store the current position that we are at. And let's give that a shortcut. So we can say character.transform.world matrix and then the translation vector, because the waypoint position is a world position, and we're going to calculate the velocity towards that next waypoint. So we also need the world position of our current character's position. Let's also store the delta time because we're going to be needing that. So we can say, I know I need to convert that value. So I'm going to say game.updateTime.elapsed and then total seconds. And then finally, let's also calculate the distance between the point that we are currently at and the next waypoint. So we can say vector3.distance. We say the current position and the next waypoint. So let's first do a little check. If that distance between the current position and the next waypoint position, if that is kind of large, then we know that we still need to keep moving towards that next waypoint. So we'll do a small perimeter check, if you will. If we're not nearby at any way, then we just want to keep on moving towards that next waypoint. So we're going to do some vector mathematics here. We're going to say velocity is next waypoint minus the current position, which we then have to normalize, and then we multiply this value with the delta time. And let's also multiply this with a movement speed. So let's call this movement speed. We still have to define this variable. So let's go up here and say public float movement speed. Let's set that to 1.5 as a start value. So we now have the correct velocity, but now we need to update our character itself. So we're going to say character.transform.position, and let's add that velocity that we currently have. So this will move our character towards the next waypoint. But let's say that it is very close to our next waypoint, so lower than that 0.1 float value. Then we want to check if there is another waypoint. We want to switch to the next waypoint. So we need to do a little check because it's possible that the waypoint that we're navigating towards to, and we're really close to it, that is the last waypoint in the entire list. So we're going to say if waypoint index, let's say that we would add one to it. If that's still lower than the amount of waypoints that we have, then we know that there is a next waypoint. So what we have to do then is say waypoint index ++. We have to increase the counter, and otherwise we are simply done with the movement. And the only thing left to do at that point is, well, we don't really have to do anything, but let's just clean up the existing path that we've already traversed and that at that point is no longer needed. So let's give this a spin. Let's build. And if we click on navigation and we start clicking in our scene, our character will move along the waypoints. And once it's reached the final waypoint, the waypoint's path spheres are being removed from the scene. So this is looking really cool. Now we've just made a script that uses a very generic approach to moving objects around the scene. Of course, this doesn't per se have to be done with a navigation mesh. This can be done with any kind of object in 3D space, as long as you have these vector 3 coordinates. If you're using an actual character collider, you can use that, of course, to update the movement using actual character physics. But for now, we have this really cool script where our character will move along these waypoints and move towards its final destination. That concludes this tutorial on navigation meshes and navigating your character around the scene.